So the main thing that we're focusing on in this lesson, as far as I'm concerned, is being able to use the slope criteria for perpendicular lines. So the book says that the two non-vertical lines are perpendicular if and only if the product of their slopes is -1. I want to extend this to say that two non-vertical lines are perpendicular if and only if their slopes are opposite reciprocals. And we've talked about this before. I believe it was in Module 5 when we were writing equations of parallel and perpendicular lines. So this shouldn't be new to you, especially since you should have seen it in algebra last year as well. So here we're using that slope criteria to show that this figure ABCD is a rectangle. So notice what they did. Very much like in yesterday's lesson, first thing you want to do is identify the coordinates of the quadrilateral, the vertices of the quadrilateral, and then we used slope to find the slope of each side, the formula for slope, and we found that the slope of these are equal and these are equal, so we know that AB is parallel to CD and BC is parallel to DA. And then if you also compare these slopes and these, you'll see that they are opposite reciprocals. And so since opposite sides are parallel and consecutive sides are perpendicular, this is a rectangle because it has 4 right angles. In this example, we're showing that this is a trapezoid with 2 right angles. So again, step 1 is to find the coordinates of the vertices. They've already identified J and K for us. We're going to identify that L is at 2, -2, and M is at -1, -1. They've already found the slope of JK for us. We're going to find the slope of KL. So KL means I'm looking at these 2 points, and so I'm filling in the blanks. I have -2 - 1 over 2 - 3. So that's -3 over -1, which is +3. And notice how these 2 are opposite reciprocal. So that looks good so far. Now I'm going to find the slope of LM. Redo that. Now I'm using these 2 points, -1 minus -2 over -1 minus 2. That will become 1 over -3, which is just -1/3. So notice how these are the same. So they're parallel. Finally, we're going to find the slope of MJ. That's these 2 points. And that will be 3 minus -1 over -3 minus -1. So that's 4 over -2, which is -2. So I also want to emphasize back here that those slopes are also opposite reciprocal. So So I have two lines, or two pairs of lines intersecting at right angles, meaning I have two right angles. So I've met this condition. I know it's a trapezoid because I have one pair of parallel sides. We saw that here. So let's fill in their blanks. Since the slope of JK is the same as the slope of LM, JK is parallel to LM. We talked about that earlier. Since the slope of JK times the slope of KL equals negative 1/3 times 3, which is negative 1, and the slope of KL times the slope of LM, all right, well, the slope of KL was 3. The slope of LM was negative 1/3. When I multiply them together, I get negative 1. That means that JK is perpendicular to KL, and KL is perpendicular to LM. Therefore, quadrilateral JKLM is a trapezoid with two right angles because perpendicular lines form right angles and JKLM has one pair of opposite parallel sides. In part B, is quadrilateral JKLM a parallelogram? Why or why not? It's definitely not a parallelogram because in a parallelogram I have two pairs of opposite parallel sides. Here they're asking us to do a problem just like what we finished doing, completely on our own. Let's start by identifying the coordinates of the vertices. D is at negative 2, 3. E at 4, negative 1. This is point E. F at 2, negative 4. And G at negative 4, 0. So I'm going to show that this is a rectangle by finding the slopes of all four sides and showing that I have two pairs of parallel sides, and I'm going to be showing that the consecutive sides are perpendicular. So slope of DE, that's negative 1 minus 3 over 4 minus negative 2. That's negative 4 over 6, which we will reduce to negative 2/3. Slope of EF, negative 4 minus negative 1 over 2 minus 4 is negative 3 over negative 2, and of course we know that negative divided by negative is a positive, so that's positive 3/2. Slope of FG. Actually, before I do that, let's notice these are opposite reciprocal. So right away, I already have a pair of perpendicular sides. Slope of FG, negative 4 minus 0 over 2 minus negative 4. So that's negative 4 over 6, which reduces to negative 2/3. Notice how those are equal. Finally, slope of dg is 3 minus 0 over negative 2 minus negative 4. So that's 3 over 2. And again, notice those opposite reciprocal slopes. So I know that this is a rectangle because it is a parallelogram. DEFG is a parallelogram since both pairs of opposite sides are parallel, and since, let's pick one, DG is perpendicular to FG, it has a right angle. Therefore, DEFG is a rectangle. And as some of you have already heard me say in class, I can't digitize this entire process. It would take forever. So what you could encounter on an assignment quiz with a question like this is you'd see the question on your screen that would say DEFG is a rectangle because the slope of DG and EF equals this, whereas the slope of DE and FG is the other thing. Okay, so that's the best way that I can digitize this kind of a question. In example 2, now we're given the equations of lines, and we're asked to classify the quadrilateral bounded by them. So this is talking about these lines representing streets on a city map. And so we have the equations of them, and step 1 is to write each equation in slope-intercept form, y equals mx plus b. So when we do that, what we're basically doing is getting y by itself. So they've already done that for us, and when they do that, the slope is right there staring at you. So when they did that, they saw that these were equal, so were these, and that we have a pair of opposite reciprocals, and therefore the quadrilateral is a rectangle since it has 4 right angles. Step 4, they have you graphing the equations and showing that the figure is indeed a rectangle. Part B, we're doing a little bit more on our own. So again, step 1 is to rewrite each equation in slope-intercept form as y equals mx plus b. So Clay Avenue is 3y minus 9 equals x. Since I'm trying to get x by itself, I'm going to start by adding 9 to both sides. So now I'll have 3y equals x plus 9. And then when I divide both sides by 3, I get y equals 1/3 x plus 3. In Fresno Road's equation, in order to get y by itself, I just need to subtract 2x from both sides. So I'll have y equals negative 2x plus 3. For the Ward Street equation, I need to divide both sides of the equation by 3. And when I do, I have y equals 1/3 x minus 5/3. And then the last equation, in order to get y by itself, I'm subtracting 4 from both sides. So I have y equals negative 2x minus 4. So the equation for Clay Avenue, again, was y equals 1/3 x plus 3, so the slope is 1/3. The equation for Fresno Road was y equals negative 2x plus 3, so its slope was negative 2. Ward Street, y equals 1/3 x minus 5/3, so the slope is 1/3. Oakland, y equals negative 2x minus 4, so the slope is negative 2. Determine the type of quadrilateral bounded by the streets. The slopes of opposite sides of the quadrilateral are, notice, these are equal, and so are these. Notice that consecutive sides, however, are not opposite reciprocals of each other. So this is a parallelogram, but it's not a rectangle. So the slopes of opposite sides of the quadrilateral are equal. So the quadrilateral is a parallelogram. Since both pairs of opposite sides are parallel. And then it says check by graphing the equation. So yes, you're expected to remember what you did in algebra last year. So first equation, Clay Avenue, 1/3 x plus 3. That means that my y-intercept is 3, and it has a slope of 1/3. So here's the first one. Fresno Road is negative 2x plus 3, so it also has a y-intercept of 3, but a slope of negative 2. So here is Fresno. Ward Street has a y-intercept of negative 5/3 with a slope of 1/3. So this is going to be unpleasant. Negative 5/3 is about here. And if I have a slope of 1/3, so rise 1, run 1, 2, 3, so about here, about here. Little human error, I think we can live with that. And the last one is negative 2x minus 4. So that's a y-intercept of negative 4 and a slope of negative 2. And here's the shape bounded by those streets. Is it possible for 4 streets to form a rectangle if each of the 4 streets has a positive slope? And the answer is no. In order for slopes to have a product of negative 1, they must be opposite signs. hence the phrase opposite reciprocal. Here we're asked to do the same kind of problem on our own this time. So once again, step one is to get your equations in slope-intercept form, get y by itself. So for Taft Road, I'm going to start off by adding 2x to both sides. So I'll have 3y equals 2x plus 13. And then I'm going to divide both sides by 3. And Taft will have the equation y equals 2/3 x plus 13 over 3. In order to get Harding-Lane in slope-intercept form, I'm multiplying the whole equation by 3. So Harding will be y equals negative 3x minus 3. Right away, I hope you would notice that these have no relationship whatsoever. So at the very least right now, you should be eliminating the prospect of this being a rectangle from your mind. It's definitely not a rectangle. In order to get Wilson Avenue in the proper form, I'm going to divide both sides by 3. So Wilson will be y equals 2/3 x plus 2/3. And now this is looking promising. Here's one pair of opposite slopes that will be equal to each other. So this could be a trapezoid, or let's look at Hoover Street. I need to subtract 3x from both sides, and Hoover is y equals negative 3x minus 14. So notice these slopes, they are the same. So this is a parallelogram. Because it has two pairs of opposite parallel sides.